So your question here is an interesting one because it shows me a couple different levels where we need to make your understanding better. When you ask, I type it into my calculator and it gives me a decimal, how do I convert it to radians? Well, does your calculator do this? When you say sine inverse, I'm looking at the first one, radical 3 over 2, does it give you 1.047, right? My calculator is in radian mode. That is radians, right? The thing is, I think people quite often think that all radians have pi's involved. It's like, I can have an angle that's 2 radians. I can have an angle that's 57 radians, right? The thing is, most of the nice angles, the ones we're used to in degrees, 30 degrees, 45 degrees, 90 degrees, these angles have nicer representations when you write them as a multiple of pi. For instance, radicals, this answer here, 1.047, is actually pi divided by 3. So if I write this as pi over 3, did I just convert it to radians? No, it already was in radians. 1.047 is pi divided by 3. It's the same number. It's just that it's written in a different way. Okay. Now, that being said, this problem is not looking for you to type them into your calculator, because this problem is all nice angles. So what I want to look at here is, if I look at sine inverse of radical 3 over 2, right? Sine is a trig function that takes angles and gives you an output of opposite over hypotenuse. So inverse sine, or arc sine, goes the other way. It takes a ratio of sides, opposite over hypotenuse, and gives you an angle as an output. So this is some angle that's in a triangle where the opposite side is radical 3 and the hypotenuse is 2. This angle right here is the sine inverse of radical 3 over 2. Using Pythagoras, I can find this other side of 1, right, because 4, so 2 squared minus square root of 3 squared, 4 minus 3 is 1, square root of 1 is 1. That this is a triangle I recognize. This is a 30, 60, 90 triangle in degrees, or in radians, it's a pi over 2, pi over 3, pi over 6 triangle. So the angle I'm talking about, where the sine is radical 3 over 2, this is pi divided by 3. It's the big one. Pi divided by 3. Okay. Sine inverse of -1, this one, remember, we're thinking of when you start dealing with negatives here, either this one or that one, the negatives have to do with x and y coordinates. So I'm thinking of sine is y over r, right? Because in the first quadrant, that's the way I like it. Y is the opposite side, this is the angle. R is here, x is the adjacent side. So to say that y over r equals -1 tells me two things. Since I always take r to be positive, well, the y has to be positive, which means I'm down below somewhere. And in order for it to equal -1, y and r have to be essentially the same number except different sign, SIGN. So if you're looking at a point down here on the negative y-axis, then the y coordinate is negative and it equals, well, r and y are essentially the same except r is positive and y is negative. So what angle am I talking about? I'm talking about the angle that goes 3/4 of the way around a circle. Well, that would be 3/4 of 2 pi, or, this is sine inverse of y over r. 3/4 of 2 pi would be 2 pi divided by, no, it would not be 2 pi divided by 3. This is pi over 2, 2 pi over 2. It's 3 pi divided by 2. There we go. When I looked at that, I knew it couldn't be right. It couldn't be a pi over 3. And then it's like, okay, count them. I know this is 1 pi over 2. That's 2 pi over 2s. That's 3 pi over 2s. That's where I want to be. Okay. This last one, sine inverse of a half. Again, sine is y over r. So, and r is always taken to be positive. So I've got an angle whose sine is -1 over 2. Or maybe it's over here, -1 over 2. And here's the wrong answer. I gave you the wrong answer, and the reason I realized that is down here. There's a lot of angles whose sine is equal to -1. There's a lot of angles whose sine is equal to -1/2. When we talk about the sine inverse, we're only talking about the smallest such angle. And in this problem, that angle is gotten this way. That's the smaller angle. So this should be -π/2. And likewise here, the smallest angle whose sine is -1/2 is this angle right here, -1/2. So this is in some negative angle, and again, we're looking at the same triangle as up there, except that now we're looking at the small side, the small angle. So that's got to be the π/6. So -π/6. Okay, I wasn't thinking completely straight here. I got myself in the right place, but forgot about the fact that arcsine is only giving you the smallest angle. It's like the square root function. You know, what's the square root of 49? Well, there's two square roots. There's 7 and -7, but when we ask for the square root, we mean the positive one. And here, when we look for the angle whose sine is -1, we're looking for the smallest angle whose sine is -1. And that angle is, in this case, a negative angle. Likewise here, the smallest angle whose sine is -1/2 is -π/6. Okay, these are all in radians. I mean, I could give you it as π/6, or I could give it to you as sorry, I'm typing into my calculator real fast. 0.52359877756. I mean, write it with the pi or without the pi, it's still in radians. Okay, I hope that helps.